Hello, everyone, and welcome to another episode of the Artistry of Code podcast. Your hosts for today are Grzegorz Godlewski,
Marek Urbanowicz,
and Artur Wolny.
Hi, guys. And we have a small announcement to make because last year in the October, Marek started the whole conversation about having the podcast. So technically speaking, we are having like 1 year of our initiative, although the first episode was released in January. So for the official birthday cake, you have to wait just a couple of months more. And in today's episode, we wanted to continue our conversation about the test pyramid. This time, we're going to reach to the very bottom, which is the unit test level. In the episode 15, we were talking about the end-to-end test. Episode 16 was about integration test. And in addition, Artur recorded the second snippet titled The Quick Guide on Sizing the Unit for Unit Testing. So you might like to reach to those episodes to gain more insights on the subject. And without further ado, let's start today's episode. Welcome to the Artistry of Code podcast, where we, together with our guests, are seeking ways of doing things right and having fun with it.
software, architecture, soft skills, teamwork, and other crazy buzzwords.
Are you ready? Let's bring more value to the business.
So the first question for today, as similar to the previous episodes, would be the definition. So how do we define unit tests? How we understand that definition?
Okay, using simple words, for me, these are the tests that are the closest possible to the code, to the unit of code that we picked. Yeah, and that's the topic that I covered in the previous episode that you, Grzegorz, mentioned in one of our snippets. So I will not focus here on how to pick one, how to pick the right unit, but the main point of unit testing is testing some part of code, rather small than big, and give you a quick feedback if the code is actually doing what you expected. And also for me, the main point of unit testing is covering all edge cases that the component that we picked, unit of code, can have. That's the most important thing, actually.
So for me, I once upon a time found the talk which Kent Beck gave on unit testing, and he said something along the lines that whenever he's having like a workshop or a training related to unit test, he's putting out like 26 of definitions of unit testing, because that's the problem which we've covered even in the first episode on the end-to-end testing, is that there is that ambiguity about the unit test. And there's really no good definition, which is precise enough. How I do define unit tests for me personally, well, I'm trying to slice the unit of my interest. So there's a piece of functionality or a piece of code which I would like to cover with some tests. And if that is not hitting towards the database, if that's not being invoked by let's say, a simulated REST call, so kind of like an integration test in my world, in my book, I would say, then for me, that's a unit test. That can be a group of classes, that can be a group of functions, that can be a single class. It all depends, what's the area which I would like to cover with my questions in the unit test. And definitely not including connecting to the database and not invoking REST APIs as part of performing that test.
To me, I would try to avoid any kind of definitions because, as you said, Grzegorz, it's super hard to really define them. But the unit tests, to me, are really testing the narrow part of the code, similar to your approach, I think. And one important detail here is that when I'm doing the unit tests, to me, they're supposed to run in isolation of the unit. Yes, so no matter how we will size the unit, the test should run in the isolation. So if something is failing, we know that this particular unit has some issue, not some surroundings of that, which would be caught in the integration tests. Yeah, so that's the great benefit of the unit tests. But also, to me, it's a requirement and part of the big definition of the unit tests is the isolation of the unit during the unit tests.
Okay, cool. So the other question which is on our list is like, why do we need unit tests? What are the benefits of having unit tests? And I'm afraid that this question is asked in many places, and in many places there are no unit tests. But then again, we would like to give some help here. So when it comes to myself, I'm doing unit tests for simply peace of mind and peace of my own mind, because I can link building unit tests to some peaceful projects which I was running. So if I was building e-commerce store once upon a time and I had some discounting logic to implement and cover, and there were different combinations of types of discount codes, and I wanted to be sure that if I'm going to push some changes to production, that the discounts and the money calculated after the discount is going to be working fine. And that was at a company which wasn't practicing unit tests, I would say, at all, but I did it for myself so that I can, confidently deploy stuff whenever I need to do it. And the other case is when I'm building my own project right now, the little startup which I'm building, unit tests actually help me to track where I'm in my implementation roadmap. Because if I'm sitting on my project, let's say in the evenings, then after some time, I'm losing track of what's implemented, what's covered. And now when I'm looking in the unit tests, I have a full list. Okay, so I've created this functionality. I'm pretty much done with it. I can move to the old one. I got this covered. The coverage on the unit tests, the code coverage is around 70% out of the box. I'm not even, aiming at a percentage there. It's just there because I've started with the tests.
I feel like having unit tests is helping us to have a better code. Especially when you utilize the test-driven development method of working. I remember once when I was a young programmer, junior one, my colleague from work told me to first specify what I want from my class, write it down as a test, and then step by step change my implementation just to fulfill all the tests that I figure out at the beginning. And I started to see the value in it. I mean, the resulting code in every step that I took on this way was the simplest possible to match new expectations given to the class with the unit test. And I feel like into normal day-to-day work, we kind of lose the track of what we want to achieve. And because of that, we can, get into some kind of pitfall that it's very hard to escape. Using tests first and writing those tests actually just moves your focus to some bigger picture, to some kind of forces you to have some kind of plan of implementation, and can reduce the risk of being stuck at some point. So this is the first point. Second point I would answer with, because tests are our best documentation. Yeah, if tests are written very well, it's very easy to figure out if some kind of unit of code can be reused elsewhere, because we know what is the behavior just looking by correctly written unit test. And this is also big of a value that on the daily basis, I believe people are not seeing on the first sight.
It's really hard to add anything on top what you said, guys, because I fully support everything what has been said already. But I would add something about the refactoring, which somehow resonates with the peace of mind. But yeah, doing any refactoring without having unit tests, it's like crazy pain, and it's so stressful because you don't know, and I didn't when I was doing some refactorings on the areas of the code which weren't covered by the unit tests. I was really scared because if the application was still starting, for example, after my changes, okay, at least I didn't break it completely. But is it working as expected? I have no idea until we will do some manual tests or something. So often. I can remember from the times when we were working together. At some areas of the code, we knew that we have to change something, but we knew that it's not safe. So we were starting first with adding some tests over the time to the areas which were super hard to cover because it was not testable at all. And then doing some big changes later on when the tests were in place. So definitely the refactoring is a good point of having the unit tests in place. And I would also really support the thing which you, Grzegorz, mentioned about the peace of mind when pushing something out. Because, we all can suffer from imposter syndrome or whatever we will call it. And we can be really stressed because we don't know if with the big change, the big feature, for example, is really working as specified. While I always do on really like complex stuff, I will always write some unit tests with like clearly explained steps, and then when they are green, I know okay, it's working, and I can safely push it.
Hey guys, I feel like we missed one important thing about unit tests and why we need them, because they give us the fastest response if our changes are correct or not. So the fact that they execute in milliseconds or usually even less is a very valuable thing, and shortening the feedback loop is always important.
And I'm smiling because I have a pro tip. We had that episode about the live coding experience, and I've told you guys that I didn't had like a proper live coding session until I did. So I had some live coding experience some time ago. And how this is connected to this subject? Well, during that live coding session, I was asked firstly to, do a warm up exercise to write a function which is going to do like an a plus b something. Let's say that's this level of complexity. And I've started that live coding session with writing a unit test. So this is something that the interviewers actually didn't expect. And later on, I've learned that was super cool for them and received very nicely. So if you're on the lookout for a job and there's a live coding session involved, you might want to skill up TDD just to have some additional karma points at the very beginning of the interview. Highly recommending this method, pays off.
Just to make show.
Yeah, and that's about like presenting yourself. So definitely they can do the job. Okay, but then again, when we are talking about the unit testing, there's the discussion to mock or not to mock. So when we have a code which has some dependencies, some of them might be troublesome. So we are in front of that question, whether we're going to mock that part of the implementation or not. So what are your takes on this?
Yeah, my take is usually mock, but it always depends. So when I have like a simple class that is doing its thing without having some side effects executed, then I do not mock, because I usually don't see value in it. For example, I also do not mock when having the mapper, because usually mappers are created for one mapping from one entity to other, from one class to other. So they can be tested along with the logic that is using the mapping. So then I don't mock. But every time when I have some kind of side effect, I do the mocking, because then it makes this isolation about which Marek said. If my code is testable, in this case, it's based on not implementations, but rather interfaces, then this isolation is total, because I depend on abstraction. I can easily create a mock or even a dummy implementation in place to meet requirements of that abstraction. If we also follow this rule to depend on the smallest abstraction possible, like not to build big interfaces, but rather combine them in objects, then it's very easy to write small, short, understandable unit tests.
To me, I mostly support this isolation stuff. So whenever I cross the boundaries of the specified unit, I will mock to maintain this isolation and not, let's say, let leak other domains or whatever units into the particular test. The one thing which I like not to mock is something which comes in play when we are somewhere on the edge between the integration and the unit ones, and it's about the repositories, and it's mostly about getting when I'm preparing like a proper DB based repository, also prepare the in-memory implementation, which is still super fast and runs smoothly without any additional setup. It satisfies the expectation of the interface, obviously, and it works much more fluently, let's say, and helps to avoid having stupid mocks everywhere in the test. So when the repository finds ID1, then return, and all the time, yeah. It gives more like fluent unit test, let's say, yeah. So there is the better flow in them, in my opinion.
We work in Node, and we noticed that, I at least noticed that in Node it's quite common to have this full libraries mocked. And that's, in my opinion, some kind of anti-pattern. Yeah, when talking about if mock or not to mock, I would say if you really need to mock, just mock that part that you really need, not the full implementation. Once I seen the, for example, IORedis mock fully written,
Or
like recreated in the memory, and I feel like it's
flashback.
a big waste.
or the AMQP lib, so the library for RabbitMQ, like fully mocked, but not really mocked. There was a stub implementation instead, right? So
yeah, of course. It's only about adding the expectations here to make it a mock, but in general, it's reflection, right? Reflection of code that you don't need. It's a waste of energy.
yeah, essentially that would be a heuristic. So if you're about to implement an in-memory IORedis implementation by your own, that probably isn't a good idea, and you should consider some mocking instead.
Or something is wrong with your code, yeah. that's the another side.
This is the other case, and when it comes for my preferences for mocking, so I primarily use mocking in cases where I would like to isolate a part which I'm not interested in testing, right? So if that's like let's use that Redis example, so that's a library of Redis, then I'm probably going to like mock it out and just assume that if I'm going to set that key, that's going to return a true value, and that's pretty much it. That's all I need in that particular place. And I really like what you said, Marek, about like the repositories, because that's actually my like day-to-day challenge right now. Because if I implemented the clean architecture according to Uncle Bob, I pretty much have like a business service, let's call it that's like an accounting service, and that accounting service depends on an accounting or like invoice repository interface. So it doesn't really rely on a particular implementation. And that's a very problematic thing to some extent, because by default, I have to go into mocking, because if would like to do a unit test of my accounting service, then I rely only on an interface. So by default, I'm going to go into mocking, because I'm not going to put there an invoicing repository or an invoice repository as a dependency, because it's having Mongoose thingies inside of it. And I really don't want to get close to Mongoose in that unit test. So I'm going to actually mock out the whole repository and then just focus on testing my logic in my accounting service, whether that invoice has been created via the repository or not, for an instance, right? So it falls again to the same area. I'm slicing out things which I'm not interested in invoking and testing and doing expectations on, and I'm just putting them away behind the mock, and that's pretty much it. So it adds some complexity to the unit test. We have to admit that, right? Because the amount of mocks which you have to produce sometimes is just like enormous, and that's a pain. And there's also one anti-pattern which I've stumbled upon. Somebody said, like, if you have mocks, returning mocks, that sounds like a problem in design in your code, when you have like multiple mocking levels and you have implement mocks which return mocks which return mocks.
Yes, sometimes this returning mocks can be also the result of bad design of JavaScript or the JavaScript libraries which we are using. But obviously, it's a red light to at least check if our code is fine. But sometimes it's caused by us trying to satisfy the TypeScript interfaces and the types to avoid stupid as unknown as any always in the unit tests. So I would love to take the opportunity to recommend the TS Mockito library, which helps a lot the teams which I worked with and I work with. And I find that people are easily getting in love with the verbosity of this library. So definitely worth checking out.
I myself personally use the Jest Mock Extended, but I don't really have like a clear preference one over the other. I've used both of them in my history. Both of them seem to be good enough to try out. So I guess you guys, our dear listeners, you might want to check both of them and make up your mind which of those mocking libraries is going to be cool for you. And Marek, you kind of started to lean towards our last question for today. So how to write testable code? How do you approach that?
Yeah, so when we came across this mocking libraries stuff, it immediately came to my mind that first of all, any sort of like external libraries like IOs, let's say, so buses, DBs, and this kind of stuff. It's coming from the clean architecture, yeah, but they should be really wrapped in some sort of wrapper adapter. And it helps a lot because I can clearly remember the quick example from my past when I was doing this service, which was scaling out while maintaining communication through the RabbitMQ. And to test it like in integration, but without spinning up the whole environment altogether with Rabbit to get the shorter feedback loop, I was able, because the RabbitMQ, the whole service bus was just wrapped inside the adapter. Within the integration tests, I was able to replace the implementation with the in-memory just shortcut. So everything what was published was immediately consumed and injected back. So that's one thing. So the not use, try to avoid the external IO libraries directly from the code. Because thanks to this, then these adapters can be tested as integration tests separately, and then everything can be used with the in-memory implementations or simple mocks, depends on the use case. And that brings me to another like critical thing, I think, with the testable code is the dependency injection. So doesn't matter if you use the functional approach or you use the object-oriented approach. Let's say always try to inject the dependencies. And I think it specifically hurt a lot in JavaScript / TypeScript because we have this easy way to import stuff directly. And then we have to use the Jest mock, which is super bug prone, and it's really also destroy the developer experience a lot while having the dependencies injected either through the constructor, through the function factory, whatever. It's just super easy, like to create an either mock or in-memory implementation.
Yeah, that's pretty much what I wanted to say, but with different words. I wanted to say avoid static binding. Yeah, avoid using in your functions that you defined variables or constants that are like defined one step higher in the scoping. So you can't then access them easily when writing a unit test. So if you write a function or you write a class or you write a service as a class, then always remember that all those things that you then would like to mock or make expectations on, make sure that you either pass them as a constructor to your service when you're using a class or as a param of your method or function. So it will make it easier for you then to prepare a dummy implementation or a mock, or make on which you can make expectations on. So avoid static binding, use dynamic binding, pass everything as parameter. That's my main idea how to write testable code.
Yeah, so you covered this ground pretty nicely. I could recommend, if you're not having like a framework for like dependency injection for JavaScript, I recently started to use Inversify. That's also based on TypeScript. That works pretty much well and pays off. Totally, when it comes for me, writing testable code is, if I would like somebody to learn how to write testable code, I would definitely say start with writing tests first, because you will have to take the simplest steps, and this will force you to make those small decisions which are going to make your testing life easier. So kind of by consequence, you're going to reach to that point where that code is testable. And also, I think you should adopt paradigm of programming, or like an architectural approach, which is enabling testing. So for me, clean architecture by Uncle Bob is definitely the way to go, because the principles inside of it are enforcing testability. They are fostering that testability. So you don't have to, like think about this yourself. You can just go there for an off-the-shelf idea and try it out. And trust me, the clean architecture is not possibly the easiest way, but definitely provides a high testability level.
Yeah, as we are on the last pro tips, I would like to mention one thing which I completely forgot previously, is that to be sure that the unit test is fine, have it red first and see that then it becomes green. So I always recommend if the test is green, try to be chaos monkey and try to break it, see it's red, fix it back, see it's green, then you are safe. Because if it was always green, I can't count the tests which I've seen in my life, which were always green no matter what you change, because they were basically written in the wrong way.
If you have always green tests, then write mutation tests for it. And then you will know if you can trust your tests.
Yeah, definitely. Okay, guys, I think this is enough for today. Thank you, everyone, for listening to this episode. Please share us your comments and thoughts on the unit tests on the platforms you listen or you watch this episode. Give us some thumbs up and subscribe to our either YouTube channel or the Spotify podcast.
Yeah, and if you haven't seen it yet, remember to watch our episode about sizing unit test. It's in the snippet series. I encourage you. I put my heart into it, and I feel like it will be valuable for you.
Yeah, this was definitely not sponsored section, but definitely worth checking out. So have a great day, everyone. Stay tested, and see you next time. Bye.
Bye-bye.
Bye-bye.
That's all for today. Thanks for spending your time with us.
Visit our page on Facebook and Twitter, leave us a comment under the episode, subscribe to the updates, and share it with others.
We would like to hear your feedback so that we can prepare more interesting content for you to enjoy. Hear you next time!